here's some homework help on 12.3 day 3, and this is on number 55. So using the derivative, on exercises 55, 56, 57, and 58, find an equation of the line that is tangent to the graph of f and parallel to the given line. So we have the function f of x equals negative 1/4 x squared, and it needs to be parallel to the line x plus y equals 0. So first, let's find the equation of the tangent line to f of x equals negative 1/4 x squared. So again, we're finding the limit of f of x plus h minus f of x over h as h approaches 0 using this function, so let's plug it in. So this is going to be the limit as h approaches 0 of negative 1/4 times x plus h squared minus f of x, and f of x is this function here, so it's negative 1/4 x squared, and this is going to be all over h. So let's simplify. The limit as h approaches 0 of negative 1/4 times, square this first, x squared plus 2xh plus h squared, and then minus a minus will become a positive 1/4 x squared all over h. So then this is now the limit as h approaches 0. We're going to distribute, so negative 1/4 x squared. Now negative 1/4 times 2 will be negative 1/2 xh, and then minus 1/4 h squared, then plus 1/4 x squared all over h. So then we can cancel out some things, combine like terms, so that goes away here. Now we have the limit as h approaches 0, and we're left with this and this. So this is negative 1/4 h squared minus 1/2 xh all over h. So we can factor out an h. So it's negative 1/4 h minus 1/2 x all over h, and that cancels. So we're looking at the limit as h approaches 0 of negative 1/4 h minus 1/2 x, and then we plug in 0 here. We find that the equation of the tangent line is negative 1/2 x. So remember what this equation gives us. This here, we can find the slope at any point on the equation f of x equals negative 1/4 x squared. So here is the slope. So we need to find an equation of the line that is tangent to the graph of f and parallel to the given line. So let's rewrite this line, x plus y equals 0. Let's rewrite it as y equals negative x, where you subtract x. So the slope of this line is negative 1. So we want a line that is parallel to negative 1. So what you're going to do is you're going to go ahead and plug that in. So y equals negative 1/2 x, and that's going to equal negative 1 because we want the slopes to be equal, right? So this is the equation of any slope on this equation, and then we want a slope of negative 1, so you set it equal to that number you want. So now this is negative 1/2 x equals negative 1, multiplied by negative 2 to both sides. You find that x equals a positive 2. Now given that the point is 2, we want to plug that back in to the original function to find the point of this line. Okay, so we're going to plug in this point 2 into the original function. So f of 2 equals negative 1/4 2 squared. So negative 1/4 times 4 equals negative 1. So the point that we have now is 2 comma negative 1. So we have that point. We have the slope of negative 1. So now we have this information. Now we use the point slope formula. Y minus y1 equals m times x minus x sub 1, and plug it in. So we have y minus a minus 1 equals m, which is negative 1 times x minus 2. So this minus minus becomes plus, so it's y plus 1 equals negative x plus 2. Subtract 1. So we find that the equation is y equals negative x plus 1. So that is the equation of the line that is tangent to the graph of f and parallel to the given line. So now let's try number 59. We're going to use the derivative. Find the derivative of f. Use the derivative to determine any points in the line of f at which the tangent line is horizontal. Use a graphing utility to verify your results. So we'll talk about the tangent line is horizontal, and then, so just note, tangent line is horizontal. What does that mean? We mean that y should equal 0. So first, let's find the derivative. So we're using the difference quotient. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So first we do the x plus h. So the limit as h approaches 0 of x plus h squared minus 4 times x plus h plus 3. So again, we plugged in the x plus h into this equation first, and then now you subtract r plus 3, and you subtract f of x, so just this whole thing here. So minus x squared minus 4x plus 3, and that's all over h. So then let's simplify. The limit as h approaches 0. This is x squared plus 2xh plus h squared minus 4x minus 4h plus 3 minus x squared plus 4x minus 3 all over h. Combine like terms, so x squared and x squared cancel, 4x and negative 4x cancel, and 3 and negative 3 cancel. And so now we're left with, let me circle it just so I can see it very clearly of what's left. We're looking at the limit as h approaches 0 of h squared plus 2xh minus 4h all over h. Now let's factor out an h. So h times h plus 2x minus 4 all over h. So then we have the limit as h approaches 0, cancel like the h's. We have h plus 2x minus 4. And if we plug in h is 0, we get 2x minus 4 is the slope at any point on this equation. So f prime of x is 2x minus 4. Now we want to find the tangent line where the tangent line is horizontal. So once you have your derivative here, what you want to know is, when does y equal 0? When does this tangent line equal 0? So to solve for it, just set it equal to 0 and solve for x. So then we have 4 equals 2x divided by 2, or x equals 2. Then to find the y value, you plug it back into the equation, and you plug it back into the original, okay? So we found that the point, x equals 2, that is where it's horizontal, but we need to find where is that point on the original. So again, we're plugging it back in. So we have 2, f of 2. So notice we're not plugging it into the derivative. We're plugging it into the original. So the equation is f of 2 equals 2 squared minus 4 times 2 plus 3. So this is going to be 4 minus 8 plus 3, or negative 4 plus 3, or at negative 1. So the point 2, negative 1 is the point on this curve that there is that the tangent line is horizontal. So in the next example, so number 63, and the 63, 65, and 67, what's nice is they already gave you the derivative. It's only asking to find points on the graph of f at which the tangent line is horizontal. So we don't need to find the derivative. We have this here already. So all we're going to do with this case, in this case, is just set the derivative equal to 0 and solve for x. So we can actually factor out a 4x here. So this is going to become 0 equals 4x, and we're left with x squared minus 1. So 0 equals 4x times x minus 1 times x plus 1. So there are 3 points at which y equals 0. So x equals 0, x equals 1, and x equals negative 1. So there are 3 points on this graph where the tangent line is horizontal. So then you find the y value. So f of 0, plug it in. That's going to be 0. So one of those points is 0, 0. Then you plug in 1. So 1 to the 4th minus 2 times 1 squared. So that's 1 minus 2, or negative 1. The last one is f of negative 1. So negative 1 to the 4th minus 2 times negative 1 squared equals 1 minus 2, which is still negative 1. So these are the 3 points of f at which the tangent line is horizontal. You could graph it on Desmos and verify that as well. So hopefully this helps you out with numbers 65 and 67.